are you from? Today I'm going to show you a set of smuggled Antarctica photos that were never supposed to leave the ice. Not tourist shots. Images that disappeared, got flagged, and somehow slipped out anyway. Let's begin. Satellite imagery once revealed a striking triangular shape in the remote Antarctic landscape, quickly gaining attention on social media and sparking widespread speculation. Located near the Ellsworth Mountains, the formation stood out for its sharp geometry and size, with each side measuring roughly 2 kilometers, comparable to the Great Pyramid of Giza. The unusual appearance led many to question whether the structure was more than a natural feature. As the images circulated, theories ranged from hidden secrets beneath the ice to remnants of ancient civilizations, or even extraterrestrial involvement. Despite the excitement, scientific analysis determined that the triangle is the result of natural geological processes combined with lighting, erosion, and perspective effects common in satellite imagery. While these explanations dispelled the more sensational claims, the incident highlighted how little of Antarctica has been explored and understood.
A strange object hovers above a remote research station in Antarctica. Giant icebergs float in strangely straight rectangular formations, and mountains, lakes, and rivers lie deep beneath miles of ice, home to ecosystems that have been isolated from the outside world for thousands of years. This series of images was captured by a webcam at a German research station in Antarctica. The station keeps its cameras on to record the weather and conditions around the base. These footage clips were later compiled into time-lapse videos. On August 10, 2012, one of these time-lapse videos caught attention. In a short segment of the video, a blurry, round object appears in the sky above the station. It is round, silver in color, and seems to hover in place rather than move within the frame. Then, as suddenly as it appeared, it vanishes. This object only appeared in a few frames. People slowed down the video, fast-forwarded frame by frame, and debated what they were actually seeing. Some pointed out that the footage was time-lapse, meaning long periods of time were compressed into seconds, making it harder to assess such brief appearances. So what do you think? An unidentified object? Were they testing something at the station? Share your thoughts in the comments below. A massive, almost perfectly rectangular block of ice lies in Antarctica, and it was not carved by humans. The image was taken by NASA scientist Jeremy Arbeck during a flight as part of Operation Icebridge over the northern Antarctic Peninsula on October 16, 2018. He spotted this unusual iceberg with its sharp corners and rectangular shape floating nearby. Then he noticed another, and then another. That day, Arbeck documented a series of these rectangular icebergs drifting in the area. The term table-shaped iceberg refers to icebergs that are flat and rectangular, resembling a tabletop. One of the images he captured, later known as Table B, shows edges that appear strikingly straight. These icebergs form when large sections of ice break away from ice shelves and are still relatively fresh, meaning wind and waves have not yet eroded their edges. Their clean lines give them a visually striking, almost sculptural appearance. What happens when a massive ice wall over 1,100 feet high in Antarctica collapses in 2017? If you want to know, I've also added a direct link to it in the pinned comment below this video. And don't forget to come back. The next discovery is about a strange mountain range in Antarctica buried under nearly 600 meters of ice. This radar image reveals a strange mountain range in Antarctica, buried beneath nearly 600 meters of ice. In East Antarctica lies a range roughly the size of the European Alps, known as the Gambert-Sev Mountains. Discovered by a Soviet expedition in 1958, these mountains remain completely hidden beneath the ice, and their shape is known only through radar imaging. The range contains jagged peaks and deep valleys and has survived for hundreds of millions of years beneath glaciers and ice sheets. Some of its rocks are billions of years old, formed when the supercontinent Rodinia forced tectonic plates together. Later shifts in the Earth's crust lifted the mountains, preventing them from being worn flat by erosion. Between 2007 and 2009, aircraft involved in the Antarctic and Gambert-Sev Provinces project used radar and seismic scanning to map the region. Scientists discovered liquid water flowing through valleys nearly 2 miles below the ice, an unexpected finding in such extreme cold. Seismic data also revealed that the mountain's roots extend deep into the Earth's crust, explaining how they have remained intact for so long. Tap the like button to let us know this content is making a difference. And if you're watching on your phone, be sure to press the hype button right below. Every hype helps this video get published to more people, and it truly supports me in earning extra income. I promise to keep bringing you even more great content. Next, if entire mountain ranges and flowing water can remain hidden beneath Antarctica's ice for millions of years, what happens when that ice suddenly opens to the ocean below? This is the Weddell Sea Polynya, one of Antarctica's strangest mysteries. It is a vast body of open water stretching hundreds of square miles, surrounded by sea ice that should be completely frozen in temperatures below -30 degrees Celsius. Much of the Southern Ocean is normally covered by thick ice, yet this giant opening repeatedly forms and sometimes lasts for months. Scientists believe it occurs when warm, deep ocean water rises to the surface or when strong winds push ice away from the area. Even so, researchers cannot predict exactly when the Polynya will appear. It was observed between 1974 and 1976, nearly vanished for 40 years, and then reappeared in 2016 and 2017. Although it looks like a simple hole in the ice, it has global consequences. When seawater freezes, salt is left behind, making the surrounding water heavier and denser. This dense water sinks, driving deep ocean circulation. Instead of small ripples, this process fuels a massive slow-moving current known as the global ocean conveyor belt, which transports heat, oxygen, and nutrients around the planet. As a result, the Polynya may influence ocean currents and weather patterns thousands of miles away, showing how a single opening in Antarctic ice can affect Earth's entire climate system. These images were taken at a lake in Antarctica. Lake Enigma lies deep beneath the Antarctic ice sheet. Although it might be expected to be completely frozen, researchers drilling through nearly 12 meters of ice discovered a hidden layer of liquid water. When a camera was lowered into the lake, scientists found microorganisms covering the lake floor. Some appeared spiky, while others resembled crumpled mats or small tree-like structures more than a foot tall. It was life in a place where none was expected. The water was not stagnant, but supplied by a nearby amorphous glacier through an underground channel. Despite the region's extreme conditions, including constant winds and high evaporation that should have dried the area long ago, the ecosystem persisted. Among these organisms were bacteria that typically cannot survive in oxygen-rich water, indicating they have adapted unique survival strategies. Many microorganisms formed microbial mats that functioned as small communities where some species cooperated while others fed on neighboring organisms. These findings revealed biological behaviors never before observed in an ice-covered lake and provide scientists with valuable insight into how life adapts to extreme environments. In 2016, a satellite captured a bizarre image over Heard Island in the southern Indian Ocean. Clouds above the volcanic island had split into 10 dark, swirling holes, each about 8 miles wide. These gaps twisted and turned like frozen vortices in the sky. At the center was Mawson Peak, a 9,000-foot-high active volcano located on Heard Island. Compared to the peaks that usually create these swirling clouds, it was relatively small, yet it formed a row of dense, powerful cloud holes. Normally, such cloud formations drift in straight, regular lines, but in this case, the holes twisted and shifted unpredictably. 10 perfectly spaced dark voids rotated above the remote volcanic island, creating an extraordinary and visually striking phenomenon. Ross Island, located in the icy expanse of Antarctica, is best known as the site of McMurdo Station, a major hub for scientific research. Alongside its scientific importance, the island is also associated with enduring ghostly legends rooted in a tragic event from 1979 when a plane crash claimed the lives of 257 people. Following the disaster, stories emerged describing strange experiences reported by visitors, including unexplained footsteps across the ice, distant voices, and sightings believed to be the spirits of those who perished. These accounts, shared over decades among explorers and researchers, have contributed to an atmosphere of mystery that contrasts sharply with the island's role in scientific discovery. The harsh Antarctic environment, combined with the memory of loss, has fueled speculation about the boundary between reality and the supernatural. For some visitors, the island feels both beautiful and unsettling, serving as a reminder of the fragility of human life in extreme conditions. Despite its haunting reputation, Ross Island remains a vital center for research into climate change, geology, and wildlife biology, drawing scientists from around the world. While researchers focus on uncovering the secrets of the natural world, the island's ghostly legends continue to endure, adding a layer of cultural and emotional depth to an otherwise scientific landscape. If the frozen silence of Ross Island can still echo with unanswered mysteries, what other secrets lie hidden beneath Antarctica's ice? Let's continue exploring. The Hoff crab, scientifically known as Kiwa tillery, is a remarkable deep-sea creature discovered in 2010 near hydrothermal vents in the Southern Ocean close to Antarctica. Nicknamed after actor David Hasselhoff for its distinctive hairy chest, this crab lives in one of the harshest environments on Earth. Hydrothermal vents release mineral-rich water from beneath the ocean floor, creating extreme conditions marked by immense pressure and temperatures that can exceed 700 degrees Celsius. The Hoff crab's most striking feature is its hairy thorax and claws, which are covered in colonies of bacteria. These bacteria play a vital role by providing insulation and likely serving as a food source, forming a symbiotic relationship essential for survival. The Hoff crab also has long, slender legs and large, sensitive claws. Though only a few inches long, it is a dominant predator in its habitat, using its claws to crush shells and tear food. As an omnivore, it forages efficiently around the vent fields. Its ability to thrive in such extreme heat and pressure is made possible by specialized enzymes and proteins adapted to these conditions. Studying the Hoff crab helps scientists better understand life in extreme environments and may lead to discoveries of new species or valuable biochemical compounds. Despite their isolation, these fragile ecosystems face growing threats from climate change and deep-sea mining, placing unique organisms like the Hoff crab at risk.
The Antarctic jerboa is a remarkably resilient organism, adapted to one of the harshest environments on Earth. Often nicknamed the Antarctic elephant, this tiny terrestrial creature measures only a few millimeters in length and resembles a small earwig. Yet it is distinguished by an unusually large tail. Despite its size, it plays an important role in the Antarctic ecosystem. Feeding primarily on bacteria, it survives in nutrient-poor conditions while contributing to the breakdown of organic matter, nutrient recycling, and soil moisture regulation. It also serves as a food source for larger organisms, forming a vital link in the food chain. The jerboa's survival is made possible by several unique adaptations. It has a short lifespan of approximately 1 to 2 years, but its ability to endure extreme cold is exceptional. The freezing Antarctic temperatures slow its metabolic rate, allowing it to survive on minimal resources. Most notably, it produces glycerol, a compound that acts as a natural antifreeze and prevents fatal ice formation within its body. This adaptation gives it a significant advantage over similar species in milder climates. Although not immortal, the Antarctic jerboa demonstrates extraordinary tolerance to cold compared to other cold-adapted insects. Its resilience has drawn the attention of scientists seeking to understand how life can persist under extreme conditions. Ongoing research into these organisms provides valuable insight into the biological strategies that enable survival in the most unforgiving environments on Earth.
Glass sponges are deep-sea organisms named for the silica-based chemical composition of their skeletons, which gives them a glass-like transparent appearance. Although they appear fragile, their skeletal structure is remarkably strong, allowing them to withstand the extreme pressures of the deep ocean. They exist in a wide range of shapes and sizes, from small solitary forms to large, complex networks of tubes, all sharing a striking and unusual beauty. Despite lacking common sensory organs such as mouths or eyes, glass sponges have evolved efficient survival mechanisms. They feed through filter feeding, remaining stationary while drawing seawater through specialized pores to trap microscopic particles and absorb nutrients. This adaptation allows them to thrive in nutrient-poor waters where many other organisms cannot survive. Through this process, they filter vast amounts of seawater, acting as natural cleaners that remove pollutants and maintain water clarity. Their rigid skeletons also create habitats that support diverse marine life, including small fish and invertebrates. In 2013, scientists discovered that glass sponge populations increase as ice shelves melt, making them valuable indicators of environmental change. Because their growth and distribution respond to shifts in temperature and water conditions, they offer important insights into the effects of climate change on marine ecosystems. The presence or absence of glass sponges can signal changes in habitat quality, pollution levels, and ocean health. Studying these organisms deepens scientific understanding of ecosystem resilience and supports the development of conservation strategies aimed at protecting marine biodiversity in the face of climate change and habitat loss. Antarctic scaleworms may appear microscopic at first glance, resembling tiny bacteria covered in odd scales, but they are far larger than they seem. These marine worms can grow to an average length of about 8 inches and are distinguished by insect-like bristles and highly unusual mouthparts. Their retractable jaws are completely inverted and hidden inside the body when not in use, then rapidly extend outward to seize prey. This remarkable feeding adaptation sets them apart from most other marine organisms. Scaleworms inhabit a wide range of ocean environments, including the frigid waters of Antarctica, where they have evolved to survive extreme conditions. Despite their intimidating appearance, they play an important ecological role by contributing to nutrient cycling and serving as prey for larger marine animals. Their adaptations reflect a broader pattern seen across the animal kingdom, in which species evolve specialized, retractable structures to improve survival in challenging environments. Scientific interest in scaleworms extends beyond their anatomy. Researchers study their genetics and evolutionary history to better understand biodiversity and the connections between species within marine ecosystems. Although easily overlooked, scaleworms reveal the complexity, resilience, and subtle beauty of life in the oceans. Continued research into these organisms deepens our appreciation of how diverse life forms adapt and thrive in some of the harshest environments on Earth. The sea spider, often mistaken for a terrestrial spider, is a marine arthropod commonly known as the cold-footed spider. Its most striking feature is its unusually large size, a result of polar gigantism, a phenomenon seen in several species living in extreme polar environments. Harsh conditions such as low temperatures, limited food availability, and minimal sunlight slow the organism's metabolism, reducing its need for oxygen. Over time, this low metabolic demand, combined with higher oxygen availability in cold waters, has allowed sea spiders to grow much larger than their ancestors. Polar gigantism has long fascinated scientists as it offers important insights into evolutionary biology and environmental adaptation. Sea spiders possess anatomical traits that distinguish them from land spiders and support their marine lifestyle. Their elongated bodies and long legs enable efficient movement through water, help them capture prey, and provide stability in strong ocean currents. As predators, they help regulate populations of smaller organisms, contributing to balance within the marine food web. Their large size also makes them a food source for other marine predators, further emphasizing their ecological importance. Studying cold-footed spiders enhances understanding of gigantism across ecosystems, including similar patterns seen in other environments. Because their population size and distribution respond to changes in ocean temperature and pollution, they serve as indicators of marine environmental health. Despite their spider-like appearance, sea spiders are unique marine arthropods whose adaptations and ecological roles offer valuable insights into ecosystem dynamics, environmental change, and the resilience of life in extreme conditions. Chinstrap penguins are known for their bold, assertive behavior and remarkable adaptability within the penguin family. Though relatively small, measuring about 76 centimeters in length, they combine agility and determination to thrive in the harsh Antarctic environment. Their slender bodies make them highly efficient hunters, allowing them to dart swiftly through icy waters in pursuit of prey. As skilled predators, they rely on speed and precision to survive in nutrient-rich but demanding seas. To find food, chinstrap penguins often travel long distances, sometimes venturing up to 50 miles offshore each day. These journeys expose them to rough weather and dangerous waters, yet they persist in supporting themselves and their chicks. Their name comes from the distinctive black band beneath their chin, which sets them apart from other penguin species. A thick layer of blubber insulates them from extreme cold, while their black and white plumage aids both camouflage in the water and temperature regulation by absorbing and reflecting sunlight. Despite their adaptations, chinstrap penguins face constant threats from predators such as leopard seals, seabirds, and giant petrels, which prey on eggs and chicks. In response, they rely on strong social behaviors and cooperative breeding strategies to defend nests and territory. Highly vocal, they use a wide range of calls for mate selection, territorial defense, and chick recognition, enabling effective communication in crowded colonies. Excellent swimmers and divers, they can descend to depths of more than 30 meters to chase fish and other small marine animals. Overall, chinstrap penguins exemplify resilience, using a combination of physical adaptations and complex social behavior to succeed in one of the most challenging environments on Earth. In the icy depths of the Antarctic Ocean lives the giant squid, one of the largest invertebrates on Earth and a creature long associated with legend. It can reach lengths of up to 14 meters and weigh more than 700 kilograms. Its long, muscular body moves smoothly through the cold, dark waters. But its most striking feature is its enormous eyes, which can grow to about 30 centimeters in diameter. These eyes, the largest known in the animal kingdom, allow the squid to detect faint light in near total darkness. Its long tentacles are lined with sharp tooth-like suckers and can extend more than 3 meters, enabling it to capture prey and defend itself. Giant squid inhabit the deep waters surrounding Antarctica, often remaining hidden at depths of nearly 1,000 meters. Their remote habitat makes them difficult to study, and much of what is known comes from rare encounters, stranded specimens, or individuals accidentally caught by fishing vessels. Analysis of stomach contents suggests they primarily feed on deep-sea fish and other marine animals, using their powerful tentacles and sharp beak to seize prey. Advances in technology have recently allowed scientists to observe giant squid in their natural environment. Deep-sea robots equipped with cameras have captured rare footage, offering new insight into their behavior. Protecting their habitat through marine conservation and sustainable fishing practices is essential to preserving the delicate Antarctic ecosystem and ensuring that giant squid and other deep-sea species continue to thrive in one of the most extreme environments on Earth. So, among all these smuggled photos and discoveries from Antarctica, which one shocked you the most? The mysterious UFO over the research station, the hidden mountains buried under miles of ice, or perhaps the colossal squid lurking in the Antarctic depths? Let me know your thoughts in the comments below.